Okay, so question 3 is a vector question using equations of constant acceleration, because we've got a constant acceleration here. Not constant speed, it might be added because we're in 2 dimensions. And we're just going to be using the various equations we know in vector form. So the first part, somewhat surprisingly, I thought, I kind of said using this equation to work out the kinetic energy given a initial velocity of 2 minus 5 and acceleration 1, 2. So in order to use this equation, we need to work out what x is. So to do that, we need to use s equals ut plus half at squared. Let's write it in vector form. X displacement as a function of t is equal to u, which is a vector t, plus half a, which is a vector t squared. So that then gives us x t is equal to u, which is 2 minus 5, times by t, which is equal to 5 seconds, plus a half times by the acceleration 1, 2, times by t squared, so that's 5 squared. And that gives us that the displacement after 5 seconds, put 5 in there actually, the displacement after 5 seconds equals to, well, on the top here we've got 25 times half, so it's 12.5 plus 10, so it's 22.5. And on the bottom we've got minus 25 here, and we've got plus 25 here, so that's 0. So that gives us the displacement after 5 seconds. So now we can use the equation they've asked us to use. So we've got v dot v is equal to u dot u plus 2a dot x. So v dot v, which is what we need, is equal to u dot u, so that's 2 minus 5 dotted with 2 minus 5, plus 2 times a, which is equal to 1, 2, dotted with x, which is equal to 22.5, 0. So that equals to, this bit here is equal to 2 times 2 plus 5 times 5, or plus minus 5 times minus 5, plus 2 times 1 times 22.5, plus 2 times 0. So this bit here will be equal to 45. This bit here will be 25 plus 4, which is 29. So 45 plus 29 is equal to 74. So that gives us the kinetic energy, which is equal to half mv squared, or half v dot v, which is equal to half m times 74, which is equal to 37 m joules. Okay, so that's the first part done, part A. So part B is all about the power generated by the force initially. Right, so initially the power generated by the force, well, in order to use P is equal to F dot V, because we know that P is equal to F dot V, but we also know that F equals ma. So that tells us that the force is equal to mass times acceleration. So that's m times by 1, 2. So that's telling us that now we can say that P is equal to F dot V, which is equal to the force, which is m12, dotted with the initial acceleration, which the initial velocity, which is 2 minus 5. So using a dot product there, we get m 1 times 2 plus 2 times minus 5, which is equal to minus 8m. Okay, and that's watts of the units. Okay, so minus 8mW. Now, some people mistakenly think that because power is a scalar, which it is, it can't have a negative. Certain scalars can have negative signs, things like potential energy, power, because it's taking energy away from a system. Some can't, for example, mass. But yeah, this is a scalar that can have a negative quantity. So it says, it wants us to explain what it means by negative. Basically, it's slowing down. Even though we've got positive components for the acceleration, because the initial velocity is 2 minus 5. So let's say just after 1 second, the velocity would be equal to 1 minus 3. And after 2 seconds, it would be equal to 0 and 1. So the point is that the speed is actually decreasing. So therefore, that's why the power is negative, because it's taking kinetic energy away from the system. So the speed is reducing, not the velocity. You'll get it right. Speed is decreasing. Or kinetic energy is decreasing, was acceptable for that mark as well. Okay, so then part C. Let's just make a bit of room for this so we can see the whole thing. Okay, so it says find the time the power generated is instantaneously 0. Well, that will actually be the same as when the velocity in this situation is at its minimum, which actually leads into the next part of the question, because that's what it's kind of led into. The speed is initially decreasing because the power is negative. Then at a certain time, the speed will start to increase and the power is positive. Obviously, in between the two, it will be equal to 0. So we just need to work out that time when the power generated is negative. Now we need to get an expression for velocity. So we can use v is equal to u plus at. That gives us that v at time t is equal to u, which is 1, 2, plus acceleration times time. So sorry, I've got that the wrong way around. Of course, that's the velocity. The initial velocity is 2 minus 5 times by a, which is equal to 1, 2 times t. Let's write that as a single vector. So that's 2 plus t and minus 5 plus 2t. Right, so now let's just use P is equal to F dot V. So that gives us that the power is equal to F, which is what we have in this first part here. So that's m times 1, 2. Dotted with the velocity, which is 2 plus t minus 5 plus 2t. Let's do the dot product with that. That's m times 1 times 2 plus t plus 2 times minus 5 plus 2t. So that equals to m, and this will be equal to t plus 4t, so that's 5t. And minus 10, so that's minus 8. So P equals to 0 when 5t minus 8 equals 0, which is when t equals 1.6. Okay, so that's the first part of that done. Now, as I said before, that will actually be the same as when the speed is at its minimum, because initially the power is negative, so speed is decreasing, and then at a certain time, which we've worked out, the power is 0, it then becomes positive. And then because the power is then positive, that means that the speed will start increasing. So that means it follows that when t is equal to 1.6, the speed is at its minimum, therefore the minimum kinetic energy. So we can say that when t is equal to 1.6, we can just use this formula here, is equal to 2 plus 1.6 and minus 5 plus 2 times 1.6. That equals to 3.6. And here we've got 3.2 minus 5, so it's minus 1.8. Okay, so that's our velocity. So we can say the minimum kinetic energy, because this is when the speed is at its least, this is the minimum speed, equals to half m, which is not given, so it's half m, v dot v, which is equal to half m 3.6 minus 1.8 dotted with itself, so that equals to half m 3.6 squared plus 1.8 squared, and that equals to 81 m over 10. Okay, thank you very much, that's it.